So welcome to another past paper video. In this one we are going to have a look at Summer 23 paper 1-3. Let's get started. So question number 1 of this paper says, what must be included in the record of a physical quantity? So any sort of quantity must always have two things, one of those being the unit, the other one being some sort of magnitude. So an integer value for the quantity is not a requirement. Let's strike that out. So being an integer value is not a requirement. In SI unit, a unit must be included, but it does not have to be SI. It could also be a non-SI unit. A numerical value of the quantity basically means the magnitude, which is the requirement. This is the answer here. And a unit expressed in base units is again not a requirement. Could be any units. It could also be derived. What is the ohm expressed in SI base units? So ohms is the unit of resistance, which is V over I in base units, right? So if I look here, this is not base, this is not base, right? So it's either of A or B. So V, if I think about this, V is work over work per unit charge, right? And this is I is I. So then if I look here, so work is joules. Now you might also want to derive this if you feel like you need to. I don't need to because I remember this. And it's also useful to remember a few of these. So this is kg meter square per second square. This is what I know by heart for work and energy. And charge is ampere second. And this is another ampere, right? So it's going to be kg meter square per second square. This is going to make it a per second cube here. And the ampere would become a per ampere divided by another ampere. So it's kg per ampere, kg meter square per ampere square per second square, per second cube, sorry. So kg meter square per ampere square per second cube. So that is obviously A here, right? Kg meter square per ampere square per second cube. Question number 3. A desk has a true width of 50 centimeters. Two students X and Y measure the width of the desk. Student X uses a tape measure and records a width of this much. Student Y uses a meter rule, records a width of this much. Which statement about the measurement of student X is correct? So A says it is less accurate and less precise than the measurement of student Y. So this is the actual value. So the measurement of student X is 49.5. This is Y, which is 51.4, which is further apart. So I know X is definitely more accurate. So it's this or this. And then about the precision. So the idea is that X has a, even though it's more accurate, it has a greater variation because of the uncertainty. So it has more of an uncertainty. So this is less precise than that of Y because Y has less uncertainty. Question 4. The diagram shows two vectors X and Y drawn to scale. So there is this X, there is this Y. If X equals Y minus Z, which diagram represents the vector Z? So basically if I rearrange from here, Z is really going to be Y minus X, right? So Y minus X basically means adding Y to the negative of X. So if this is how X is, negative X is going to be the same length of arrow but downwards because this is now negative X, right? And then I can also choose to basically play around with where this is placed. So if I place this here, so you can see that now this obeys the head to tail rule. So I just join these and this is going to give me the resultant, which is really Z here. So it's obviously A if you just look at the directions. Question number 5. Which equation representing uniformly accelerated motion in a straight line can be determined using only the definition of acceleration. You don't even need to have a look at the options for this. You need to know that the definition of acceleration is this, and you rearrange to make v the subject, so that's v equals u plus at. Other ones do require other equations. So an object moves from rest with uniform velocity horizontally and uniform acceleration vertically. Which graph showing the variation with time t of the displacement of the object from its initial position is correct? So a couple of points to note here. First off, you have a graph of horizontal versus vertical displacements which is given, and it's moving from rest with uniform velocity horizontally and uniform acceleration vertically. So if you think about the velocity, because it's uniform velocity horizontally, this means that because I have a displacement time graph in all cases, and that's a difference between them, some are horizontal displacement graphs, some are vertical displacement graphs. But if I'm talking about the horizontal component, if the velocity is constant, that means the gradient is constant, because the gradient is velocity. So for the gradient to be constant, it must be an upward sloping straight line. So it definitely cannot be a graph with horizontal displacement on the y-axis, right? Because all of these graphs are curves and we need a straight line like this. And uniform acceleration vertically. Which graph shows the variation with time of the displacement of the object from its initial position? Also, another thing that you may note here is that it starts from rest, and because gradient is velocity here, if it starts from rest, this also means that the initial gradient would be the initial velocity, and here it must be 0. If I were to draw a tangent to this point, it's obvious that this tangent is not 0. That's why this cannot be the option either, and this is what it must be, right? So that's the answer to this one. Also, because this is uniform acceleration, this means that velocity is increasing, hence the gradient should increase and it should be getting steeper. So these are like, basically there were 3 points to consider, but we reached our answer using just the 2 points that were given in this question. Alright, question number 7. A device for spraying paint consists of a box with its faces horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into a box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. The paint is ejected at a speed of 2.5 meters per second through 400 holes, each of area 0.4 mm square. Density of paint is given. What is the horizontal force required to hold the device stationary as it ejects the paint? So the idea is this, that as this paint would be ejected, basically there is a force which the device applies on the paint. By Newton's third law, there would also be a force that the paint applies on the device backwards. And because of Newton's third law, both of these are equal. So here I need to find the force. Now this is the case where you have the paint which is ejected with this speed. You know the total area corresponding to each of these holes, and you also know the density. So you need to find the force here. So if I think about this, I know speed, I know area, and I know density. So the equation that comes to mind is this one first, which is rho AV. This gives us the mass flow rate, which is how many kgs of paint goes through in a second. And then if I use the definition of force as delta mv over delta t, so m dot, the mass flow rate, is just rho AV. So multiplied by another v, that would become rho AV squared. So that's really what I have to calculate. Rho here is 900. Area of all of these holes, so 400 times 0.4, and there's the mm square. So to convert it into meters, because 1 millimeter would be 10 to the negative 3. This is a square, so there is going to be a 10 to the negative 6 here, and there's going to be times 2.5 squared as well. So when you solve this, you will get the answer for the force is 0.9 newtons. Let's go on to 8. So each diagram illustrates a pair of forces of equal magnitude. Which diagram gives an example of a pair of forces that is described by Newton's third law of motion? So the third law we also just had a look at above. So equal forces in magnitude acting in opposite directions but acting on different bodies as well. If I look at the driving force and the resistive forces, they're acting on the same body, so it cannot be this. Gravitational force exerted by Earth on Moon and the gravitational force exerted by Moon on Earth, both of these are equal and opposite and acting on different bodies. This is my answer. C is wrong for the same reason, that the support force and the weight are acting on just the box, and D for a similar reason. Another thing that you might also identify here is that in Newton's third law pairs, the types of forces are also always the same. So if one is a reaction force, the other one also has to be a reaction force. In this case, the Newton's third law to this force, the reaction pair to this force would be, because this is right now the force exerted by the floor on the box, it would be the reaction force exerted by the box on the floor. Right, so it always has to be the same type of force as well. On to question 9. So question 9 says two balls of identical shape and size but different masses are falling through the same liquid. The sum of the drag and upthrust acting on each ball is equal to the weight. So if they're falling, if I were to just label these forces, let's do that here. So upthrust is naturally upwards, weight is downwards, and because this is moving down, the drag is going to be upwards. So what this statement says is that the drag and the upthrust is equal to the weight, right? So it's balanced. So forces are balanced, acceleration is 0, it's moving at terminal velocity. Which statement about the two balls is correct? The first one says the heavier ball has a larger acceleration than the lighter ball. Now this statement is flat out wrong, because if for each ball the forces are balanced, then this means there would be no acceleration at all for the heavier or the lighter balls. So this is out. Part C says the heavier ball is falling at the same speed as the lighter ball. This is not true, and that's why our answer must be option D, and let me explain to you why this is the case. If the ball is heavier, it means its weight is greater. And also keep in mind that they are of the exact same shape and size, so this means volume is the same. So upthrust acting on them is also the same. And if it starts out initially, this means that if the weight is greater, the drag force has to increase more until the sum of these become equal to the weight. So in that case, it has more room to accelerate, right? So for this case, the heavier ball, because it has a greater weight, the drag force has to increase more until their sum equals the weight, so it has more room to accelerate, so it's falling at a larger speed than the lighter ball. So the answer to this one is D. Let's have a look at the next question. Question number 10. A perfectly elastic collision occurs between two objects X and Y. The thing to note in this first sentence, this, a perfectly elastic collision. The mass of X is m, the mass of Y is 4m, object X travels at a speed v before the collision and speed 3v by 5 in the opposite direction after the collision. Object Y is stationary before the collision. What is the kinetic energy of Y after the collision? Now there are a couple of ways you can do this. The simplest way seems to be this, that because it's a perfectly elastic collision, the kinetic energy is conserved. So you can just say that the kinetic energy before collision must equal the kinetic energy after the collision, right? So obviously talking about totals here. So we can say that if we're doing this, we can say that the initial kinetic energy is just half mv square, and then the kinetic energy after the collision is half m 3v by 5 squared, and this kinetic energy of y is what I want to find, right? So this then becomes 3 over 5 squared, so this becomes 9 over 25, so 9 mv square over 50 plus what I want to find. This should equal the half mv square, right? So half minus 9 over 50 is like 1 minus 18 over 100, right? So that would become what? So basically 25 minus 9, right? 25 over 50 minus 9 over 50, make it 16 over 50 mv square. This is the easy way, or somebody else what they would have done, and that is undoubtedly the longer way, is that first you calculate the relative speed of you say that the relative speed of approach equals the relative speed of separation, using which you calculate this, and then you calculate the kinetic energy. That's also not very lengthy, but this is just the most intuitive thinking. What would be definitely longer is to use conservation of momentum here, and then to calculate this velocity v, and then to use it in the kinetic energy formula. Question number 11, what is not a requirement for two forces to act as a couple? The forces act in opposite directions. This is a requirement. We are asked for what is not a requirement. The two forces act through the same point. This is not a requirement. This is true. They should have zero resultant force, also a requirement. Having equal magnitudes is also a requirement. Question 12. A uniform meter rule is pivoted at the 34 centimeters mark is shown. The rule balances when a 64 grams mass is hung from the 4 centimeter mark. What is the mass of the meter rule? Because this is a uniform rule, this means that its center of gravity will be right at the center at the 50 cm mark. So this is its weight W. So it's at the 4 centimeters mark. So this distance, this distance from this pivot, right? From this pivot, so 34 minus 4, so this is 30. This distance is 30. And from 34 to W, this distance is 16. So 30 times 64 equals to 16 times W. And from here you just make W the subject, so this would be what, 4, and 30 times 4 is 120 grams. A volume of 1.5 meter cube of water is mixed with 0.5 meter cube of alcohol. Density of water is this much, density of alcohol is this much. Volume of the mixture is 2 meter cube. What is the density of the mixture? So if you look at this here, you know the volume of the mixture. So then the only other thing you need is the mass of this mixture. You can calculate this using the densities given. So rearranging the density equation, m equals to rho v. So one of these masses would be for water, so that would be 1000 times 1.5. So that means 1500 kgs of water. And then similarly for the other one, you do that again. So 800 times 0.5, this would be 400 kg. So 400 and 1500 is 1900 kg, and then divided by this 2 meter cube. So 1900 over 2 would make it 850 kg per meter cube. Question number 14. An object is falling at a constant speed through a viscous liquid. Fu is the upthrust. WL is the weight of the liquid displaced by the object, which you know is equal to upthrust, right? Upthrust is calculated using this idea that the upthrust equals the weight of liquid displaced, right? So Fu equals to WL. If I see that, that's going to be my answer, which I do. So that's A. And WO is the weight, right? So Fu and WL were the same thing, which is why we just ticked off this one. So that's the answer here. Question number 15. An airport has a mechanical system for moving luggage. The system uses a horizontal conveyor belt, a sloping conveyor belt, a lift, and a frictionless slide. A suitcase is moved around the airport. So this is our horizontal conveyor belt. This is the sloping conveyor belt. This is the lift. This is the slide. Right? So there's a slight mismatch in the order. The sloping conveyor belt is the first thing here. Resistive forces opposing the motion of the suitcase are negligible. So it means that there is no friction throughout. For which movement of the suitcase is the net work done on the suitcase the greatest? So A says moving the suitcase a distance of 8 meters at constant speed up the sloping conveyor belt. So 8 meters up the sloping conveyor belt. So the idea here is that if I want to talk about the net work done, so the idea here is that I am again making it go through a height. But if I think about this height, if this height is 8, and let's say if this angle is theta, right? So I'm making it go through, so this is the weight of the object. So I'm making it go through W, and there's the 8 sine theta here. Right, 8 cos theta would obviously be this one. This is not what we want. We want the vertical one, so that's the sine component. So W times 8 sine theta. Part B, moving the suitcase a distance of 16 meters at constant speed along the horizontal conveyor belt. So if you're talking about the net work done, the idea is that if it is moving at constant speed and if it's not even gaining any height, so this means that there is no extra energy which this gains, so there is no net work done here, right? Again, the word here is net work done. So there is no net work done here. If we look at this, so in this case, it does go through a height of 10, so it would be just W times 10. And in this one, what's happening here? So in this one, the idea is that there would be no work done on the suitcase. Basically, it's losing this GPE which it had gained. So this is not a case in which work is done on the suitcase. Rather, we would say that because it's losing energy, we would say it's work done by the suitcase, because it's now using this store of energy it had to come down the slope. So it's not this, and it's not this. So what's greater, 10W or 8W sine theta? So W is the common denominator here. We just need to compare 10 and 8 sine theta. Sine theta is always a value between 0 and 1. So this thing is at max going to be equal to 8. Otherwise, it's always going to be less than 8. So obviously, this is the greater one. So when it goes to the 10 meter height, so that's the correct answer in this case. So this was a slightly conceptual question. A car moves along a horizontal road with a constant velocity v against a resistor force F. If it is moving at constant velocity versus the resistor force F, this means that whatever driving force it produces is equal to this. So if this is F, if this is F, this is also F. The engine of the car has an efficiency of 25%. What is the input power to the engine? So what can we do here? So we have force, we have velocity, and we need to figure out the input power. So this should be a hint to us that because we have provided the force F and the velocity V, so we can calculate the output power. So that's going to be P equals to FV. This is the power which is developed by this force here. So input, so this is output. So since efficiency is output over input, right? So since efficiency is output over input, I need input. So that's going to be output over efficiency. So over 0.25. So FV over 0.25, which would basically make it 4 times FV. So that's C. An object of mass 0.4 kg is projected into the air and follows a curved path above horizontal ground. So obviously projectile motion. The object takes a time of 1.5 seconds to move along its path. the object lands a horizontal distance of 18 meters from its initial position. Air resistance is negligible. What is the kinetic energy of the object at its max height? Very obviously, it can't be zero, because this is not a case where we are just throwing an object up in the air that it actually comes to rest. Here the idea is that even though the vertical component of the velocity will be zero, there's the horizontal component which is taking it through here. So now let's have a look again at what information was given to us. So the object takes a time of 1.5 seconds to move along its path. So this takes 1.5 seconds. So we can obviously say that in coming up to here, this would take 0.75 seconds. The object lands a horizontal distance of 18 meters from its initial position. All right. So we didn't even need to identify this. The idea is this, that if it travels a horizontal distance of 18 meters and it takes a time of 1.5 seconds to go from here to here, I can calculate its speed, which is basically going to be the horizontal component of its velocity. So distance over time, because in the horizontal component there is no acceleration, right? So 18 over 1.5, so this turns out to be 12, and now I know that this is 12 meters per second throughout, right? So at the top there's going to be just the 12 of the horizontal velocity. There will be no vertical component, so I just have to use half mv square, then half into 0.4 into the square of 12, so 144 times 0.4 divided by 2 is 28.8, 2SF 29 joules. Question number 18. A metal wire has length 5.2 meters, diameter 1 mm. The metal has Young modulus 360 gigapascals. The wire is fixed at one end and a force is applied to the other end. The force extends the wire by 7.2 mm. The wire obeys Hooke's law. What is the force applied to the wire? So here we have Young modulus given. So the first thing that comes to mind is this equation. And now you can rearrange to make force the subject. So EAX over L. So E is given as 360 giga. So 360 into 10 to the 9. Area is not given. You have to find it using the diameter. So pi, and then there's the 1.0 into 10 to the negative 3 pi d square over 4. And the extension was 7.2 mm. So times 7.2 into 10 to the negative 3 as well. And then divided by all of the length, which is 5.2. Right? So you just plug all of this into the calculator and the answer you get is 3.9 into 10 to the 2. So option B. Next, question number 19. The graph shows how the length of a spring varies with the force applied to it. The spring has unstretched length L0 when a force F is applied. And when a force F is applied, the spring has length L1. What is the work done in stretching the spring to length L1? So again, you can just use half Fx, half the force is F, and the extension is the new length minus the original. So half F L1 minus L0, option B, very straightforward. Waves are starting now. A progressive wave of frequency 1.5 kilohertz is traveling in a medium at a speed of this much. What is the minimum distance between 2 points on a wave that have a phase difference of 70 degrees? All right. So now remember that phase difference you can calculate in either of two ways. You can either calculate how far out they are in with respect to time, and you multiply that by 360 degrees or 2 pi radians. Because this is in degrees, I'm also using this in degrees. Or another way is to use how far their distance is in terms of the wavelength, and you multiply that by 360 as well. So because they are asking me for the distance, I'll use this one. And first I need to calculate the distance using this equation. Right, so lambda would be V over F. So lambda is going to be 340 over f, which is 1500. So here if we have, so first we must calculate lambda. So this turns out to be 0.227. So if you then just use this equation and you say this, that this distance apart and the wavelength is 0.227 times 360, this equals to 70 degrees. So you just rearrange then. So this would become 70 times this thing divided by 360. So this turns out to be 0.044 meters, which corresponds to 4.4 centimeters. Now question number 21. Graph 1 shows the variation with time of displacement at a fixed distance along a progressive wave. Graph 2 represents the same wave and shows the variation with distance of displacement. So this one of these graphs is displacement time, the other one is displacement distance. It's very obvious that from this one you can get the time period, from this one you can get the wavelength, and then it's really easy to find the wave speed using lambda over t. So if I look at lambda here, this is 120 centimeters. So all the units are also in centimeters, so nothing to worry about here. And the time period is 0.4 seconds. Right, so if I use v equals to lambda over t, this turns out to be exactly 300 centimeters per second. Question number 2, a vehicle moves with constant velocity along a road directly towards an observer. The observed frequency changes as the vehicle moves past. You know the name of this phenomena is the Doppler effect. The change in observed frequency because of relative motion between a source and an observer. An EM wave has a wavelength of 2.1 centimeters in a vacuum. So if I think about this, this is in the order of magnitude 10 to the negative 2. So which one is this? So the longest one is radio waves, which is usually some meters, some order of meters, some hundreds of meters. The next one after that is this, which is a microwave. So that's 23B, 24. So a source of plane polarized light is observed through two polarizing filters. The filters are positioned so that the source appears at its brightest. One of the filters is then rotated clockwise and the other filter is rotated anti-clockwise through the same angle. How does the source appear when both filters have been rotated 90 degrees and 180 degrees from their initial positions? So in the initial positions, you can see that both of these have their transmission axis vertical. So if you have light which is going in, and let's say if that was vertically polarized as well, so all of the light goes through. So the source appears the brightest. And then we rotate one of these clockwise, the other one anti-clockwise. So it says how would they appear, how would the source appear when both of these have been rotated through 90 degrees. So if this is rotated through 90 degrees, so the transmission axis in this case would be like this. So pointing this way, if you just add directions, and like this, right? So what would happen here is that the source would not appear at all. This is the idea here. Because if you look here, this angle is going to be 90, right? So the angle between the vertically polarized light coming in and this one is 90, and cos 90 is 0. So this intensity going out would be 0, and hence this would also be 0. So this would appear at its darkest. And if you rotated 180 degrees from its initial position, so if previously the filter was pointing like this, now the only difference is going to be that it's going to be pointing this way, right? Similarly, if it was like this before, it's now going to be pointing like this. So you would still have the brightest, all of the vertically polarized light would still be going through, and you would have the max brightness of the source. So the answer to this one is C. Let's have a look at question number 25. So this says the diagram shows a string stretched between two fixed points x and y. There is a stationary wave on the string. The solid curve shows the string at a position of max displacement at time t naught. The dashed curved line shows the other position of max displacement. The straight central dashed line shows the mean position. Point S on the string is directly above P. Point T is directly below Q, and this is what is shown. Which diagram is correct? So if you look here, P and S are basically the antinode positions, right? This is the antinode, this is the node, and this is another antinode position. So which statement is correct? A short time after T naught, so we are shown the max displacement line, the solid one, which is at T naught. A short time after T naught, point R on the string will be displaced. This is false because this is a node, this will never move. A short time after T naught, points S and T on the string move in opposite directions. This is absolutely true because this will move downwards, this will move upwards, and it's also agreeing with the idea that when we have points on adjacent phase, points on adjacent loops, they're in antiphase, and this is true. So this is the answer. P and Q is one wavelength. No, it's not. This is an antinode to an antinode distance, which, like a node to node distance, is half a wavelength. 2 points on the string that are equal distances from point R vibrate in phase. Again, not true. If I take a point which is here and I take another point which is here, they're obviously in anti-phase. How we talk about phase is in terms of loops. All points in a loop are in phase and adjacent loops are in antiphase. The variation with distance x of the intensity I along a stationary sound wave is shown. So this must be a antinode for it to have max intensity, and this must be your nodes, right? Speed of sound is given, we are asked the frequency. So node to node or antinode to antinode distance is half the wavelength. So I can see from this graph that lambda by 2 is 10 centimeters, which is basically 0.1 meters. So lambda is 0.2 meters. So if I use V equals to F lambda, then so F equals V over lambda, right? So this should turn out to be, and this turns out to be 1700 hertz. 27. An experiment is set up to demonstrate the diffraction of water waves in a ripple tank. The waves pass through a gap of width W and some diffraction is observed. The wavelength of the waves is now doubled. What is the new gap width needed to cause the same amount of diffraction as before? So here the wavelength was doubled, right? So the wavelength of the waves is now doubled. So what should happen to the gap width? So the very simple answer is this, that for them the gap width and the wavelength to still be equal, the width must also be doubled, right? So this is the answer to this one. 28. Two coherent EM waves are traveling in a vacuum. The two waves meet at a point. At this point, the two waves have different intensities and hence they would also have different amplitudes. Which statement about the waves is not correct? They have a constant phase difference at this point. This is correct because coherence by definition means that their phase difference is constant throughout. And for the phase difference to be constant, their frequency must also be the same. So this is also correct. So this cannot be the answer because it's asking for a not correct statement. They travel at the same speed. Again, if they are two electromagnetic waves, they have the same speed, the speed of light. And as we just discussed, because intensities are different and frequency is the same, this means amplitude is different, right? So this is not correct. In your syllabus, you are just supposed to know this link between intensity and amplitude, but in reality, intensity also depends on frequency, but it couldn't be the case here because they were coherent. 29. A parallel beam of light of wavelength 600 nanometers is incident normally on a diffraction grating. The distance between adjacent slits in the grating is this much. A screen is placed parallel to the grating at a distance of 1.5 meters from the grating. Third order maxima observed at two ends of the screen as shown. What is the distance between the two ends of the screen? So we need to find out this distance. Alright, let's see what we can do here. So we know lambda, we know d, and if I think according to the diffraction grating equation, I can find out theta as well because I also know n, right? So let's do that first. Sine theta equals n lambda over d, so 3 times 600 nano over d, and d is 2.0 into 10 to the negative 6. So from this, let's first calculate theta. So theta turns out to be 64.158 degrees. Sine theta was actually exactly equal to 0.9. So now we need the distance between two ends. So we need this distance all the way here. And you can see because of symmetry, it would be equal to, so two of these distances would make this entire distance, and this would be equal. So if I want to figure this out, I know this angle, theta, which is 64.1516, right? And I also know this distance, which is 1.5 meters. So using a trigonometric ratio, I can calculate this. So obviously we'll use tan. We have adjacent, we need opposite. So tan theta equals opposite over adjacent. So opposite here is adjacent times tan theta. So adjacent is 1.5 times tan 64.16. This is only one of these lengths. So I would also multiply by 2 to get the total end-to-end length. So tan of our answer times 1.5 times 2 turns out to be 6.19. So 2SF, 6.2 meters. Alright, let's go on. 30. A metal wire is connected between terminals of a cell so that there is a current in the wire. Which statement is correct? Negatively charged electrons in the wire from the negative terminal move from the negative to the positive terminal. This is true. Why is B wrong? Nuclei do not move. Electrons are responsible for what do you call it? For the flow of current, flow of charge, basically current. And there are no positively charged electrons, so wrong, wrong. Positively charged nuclei again do not move. Two resistors of resistances R to R are connected in parallel with a battery of EMF 12 volts, negligible internal resistance. Total power dissipated by two resistors is 36 watts. What is the value of R? So what I'm thinking here is I can choose to find the current by combining these resistors and then finding a current. But because this is also symbolic, the current would also be symbolic. So I could use P equals to VI as well. But again, I would need the current, right? If I use I square R, again I would need the current. Let's just use P equals to V square over R. That seems the most straightforward approach. First of all, I'll need to combine these resistors. These are two resistors in parallel, so product over sum. So R times 2R over R plus 2R. So that becomes 2R square over 3R. So 2R over 3, right? So V is 12 square of this over 2R over 3. This is equal to 36. So rearranging, 12 square is 144 divided by 36. So 2R over 3 equals 4. So R would equal to so R would equal 6. All right. So that's the answer to this one. 32, a wire has a length of 3 meters, resistivity this much, potential difference is applied so that the current is this much. So obviously I can find the resistance using that, V over I. So 12 over 1.4 turns out to be 8.57 ohms. Then I use acceptance equals to rho L over A. So rho is 4.9 into 10 to the negative 7. Length is 3. Area we need to find, and this is equal to 8.57. So we just need to rearrange now. So 4.9 into 10 to the negative 7 into 3 divided by the answer. Turns out to be 1.715 into 10 to the negative 7. So B. 33. A cell of negligible internal resistance is connected in series with a thermistor, a fixed resistor, and an ammeter. The thermistor is placed in a beaker of water and the temperature of water is slowly increased. A graph of current versus temperature is plotted. Which graph could show the variation of I with T? Alright, so first off, this is a series combination. If you feel like this is a bit difficult for you to just read, you can also make it. So this is my fixed resistor, this is my thermistor, and there's the ammeter, which basically just goes on to show the current, so I'm not making that. So it says that the temperature increases. This would mean that the resistance of the thermistor decreases, right? So the total current increases, right? So total current is increasing. That only happens in B, so it's that. Now let's say that one of these options was the current starting out with the same shape but from the origin. That option would still be wrong, because even when the temperature here is 0, right? And by 0 I mean, for example, 0 degrees Celsius. Again, that would have to be labeled for the examiner to ask that question. But even if it is at 0 degrees Celsius, this would mean that it still has some resistance, even though a very low one, but some current would flow still, right? So the current would not be 0, which is why in that case as well, this option would be wrong and the answer would still be B. A battery with internal resistance is connected to a parallel arrangement of two resistors and a switch S as shown. Initially S is open. What happens to the voltmeter and ammeter readings when switch S is closed? So with switch S closing, this resistor now has another one in parallel, so the overall resistance goes down here, right? So overall resistance goes down, current obviously increases, and because this resistance goes down, the what this detects, this voltmeter, what this detects is the terminal potential difference, right, across the cell. So that's E minus I R. So if the ammeter reading goes up, this means that now there are more volts lost across the internal resistance, so VT, and hence the voltmeter reading goes down, so decreases. So 34A. 35. Kirchhoff's first law states that the sum of currents entering equals sum of currents leaving. This is based on the conservation of a physical quantity. What is that quantity? Charge. Easy. Two resistors have a combined resistance of 34 ohms when in series. Let's zoom in here. The same resistors have a combined resistance of 7.4 ohms when in parallel. What is the resistance of one of the resistors? So nowhere here do we see that it's identical resistors, right? If it's identical, then I wouldn't even need the other piece of information and I would just calculate it using any one of these statements, but it's not identical. So I can say for series, I would say R1 plus R2 sums of resistance equals 34. And for the other one, I would say because they are in parallel, so in parallel, I would say R1, R2 over R1 plus R2, this equals 7.4. And now these are just two simultaneous equations that I have now. So I should make any one of these the subject. But there is still a simpler way to do this if you identify that R1 plus R2, just 34 is here. So I can say R1, R2 is 30 over 34 equals 7.4. So from this I can say that R1, R2 So 3.4 times 34 times 7.4, R1 R2 is 251.6, and then I can say that if I look here, so 34 minus R2 is R1, so R2 times 34 minus R2, this is 251.6. Yeah, but again this didn't really simplify things, because this does lead to a quadratic equation back again. Now you can use your calculator for this. That's what I'm going to do. So one value of R turns out to be 23.11 and the other one turns out to be 10.88. So if I look at the options here, I don't have any 10.88, so 23 must be the correct one. This is one way to do it, and again somebody who doesn't like math, probably they don't prefer this method too much. So another way is to just try it out for all the different options. If you have 23, so 23 plus this should equal 34, so the other one is 10 point whatever, and then you use that for the parallel combination, it should give you 7.4. So you can try it out for all the options, and whichever one clicks, that's your correct answer. A potentiometer circuit is used to investigate the EMF of a cell X. EMF of a cell X is known to be approximately 0.5 volts. The driver cell has negligible internal resistance and an EMF of 2 volts. The sliding contact has moved along the uniform resistance wire between ends Q and P to a point where the reading is 0. What is an expression for the approximate length QP? So if this is 0.5, so this means that 0.5 over 2, this should be equal to this length over this entire length, right? So 0.5 over 2 should equal QP over QR, right? So it's 0.5 over 2, which is 1 over 4 QR. So that's A. Pretty easy, right? That's how we use the null methods with potentiometers. 38. The table contains data for 4 different nuclei P, Q, R, and S. Which 2 nuclei are isotopes of the same element? So basically the same proton number is what we're going for. So we have nucleon number and neutrons. So nothing about protons here then. So nucleon number and neutrons. All right. So we can calculate the proton number, right? Because 10 minus 5, the nucleon are the total number of neutrons and protons. So 10 minus 5 is 5, 10 minus 6 is 4, 14 minus 6 is 8, and 16 minus 8 is also 8. So these are the same proton numbers, R and S. So 38D. 39, which statement about beta negative decay is correct? So in beta negative decay, a neutron changes to a proton and an electron and an antineutrino are emitted. This is correct. Neutron changes to a proton, it's correct till here, and an electron and a neutrino are not emitted, and antineutrino is emitted. Similarly, in this one, the order is wrong. It's a neutron to a proton, and a proton to a neutron, again, is wrong order, and the name of the lepton here, the other lepton instead of the electron, is also wrong. What is the core composition of a hydrogen 3 nucleus, 3H1? So we have basically one proton and 2 neutrons here, right? A proton is UUD, a neutron is UDD. So 2 and 2 makes it 4 up quarks. And yes, obviously the other one must be 5 down quarks. So 2 and 2 is 4 from here, and 1 from here makes it 5.